Alrighty. Okay, so another problem from the most missed collection. Number 10 says one of the factors of the quadratic equation 3x squared plus 14x plus 8 equals 0 is x plus 4, which produces a root of x equals negative 4. What's the other root of this equation? The good news about this problem is that if you have a graphing calculator, if you know how to work a graphing calculator, you can solve this. I hate to say it like this, but basically with doing little to no math. If you graph this equation, you will find out it does have two roots. And using the TI graphing calculator, the commands are second trace, which jolts you into your calculate menu, and you have to trace a 0. We're looking for zeros, or roots, same thing. Real roots, actually, the same thing as zeros. It's going to ask for a left bound and a right bound, so you know what you can do is, this one's the negative 4 here. What you can really do is say, this is your left bound, use some point up here as your right bound, sort of zero in on that root, and the calculator will give you a value like x is equal to negative 0.666. Depending on how many decimal places it has, it'll eventually round that to a 7. And if you know fractions and decimals pretty well, you can pretty much evaluate that as C is the correct answer. But what I really want to do is look at the traditional way to solve this, and that is to solve this equation by factoring. So let's take this equation, let's just solve it straight up by factoring. So remember that the rules for if you have a leading coefficient, you need to multiply your leading coefficient by constant terms, 8 times c. 8 times 3 is 24. And we need to find factors of 24, which add up to 14. So list out factors of 24. 1 and 24, 2 and 12 is 24. 3 times 8 is 24, obviously. 4 times 6 is 24. We know that's it because it's not divisible by 5, and once you have 5, you hit 6 again, so we've looped back around. Since everything's positive, I can split these into positive factors. Each one has an x and an x. Which of those numbers add to 14? So if you can make a list of the sums. This would be 25, that's too large. 12 and 2, well, we found it actually, that's 14. But just for the heck of it, 8 and 3 make 11, and this makes 10. So what we're looking for is these two factors, 2 and 12. We insert them here, but we do have to remember to divide out the leading coefficient. Fractions become simplified, as in this one, 12 over 3 is just 4, so that's x plus 4. And this fraction, because it doesn't simplify, take the denominator and you push it in the front of the factors, so it becomes 3x plus 2. That's one of the ways of solving a quadratic like this, by factoring. And of course, to get your other roots, this root it's already given us, so we can disregard that. All you have to do is set this value equal to 0 and solve. So minus 2, so 3x is negative 2. Divide by 3, x is negative 2/3. So the answer is C. Now here's a different way completely to think about this problem. Forget about factoring everything out completely, because we already have one of the factors known to us. So here's something interesting that we can do. Write this out as two factors. This must be equal to x plus 4 is one of your factors, and then I really don't know the other factor, but if you think about the box method, we can actually kind of work backwards here and see what fits in where. So your answer, your quadratic itself is 3x squared here. These two middle terms we're not quite sure of, but we do know that the constant term is positive 8. one of your factors is x plus 4. So you could think about this as a division problem, or a series of division problems. What do we have to multiply x by to get 3x squared? Well, the answer to that would be 3x. Now, if you kind of do a little tic-tac-toe here, if that's 3x, we have to multiply 3x by 4 to get this term. So 3x times 4 is positive 12x. And then to find this number, we can also work backwards. We know the constant term here is 8, and this number is 4, so you're really asking what times 4 is 8? And the answer to that, of course, is positive 2. And filling in the blank, we have positive 2 times x plus 2x. Let's make sure we did that right by examining your like terms, that's these two, cross from each other. Add everything up. That equals 3x squared. 12x and 2x make 14x plus 8. So we do have our original quadratic. What we just did is we found the other factor. The other factor must be 3x plus 2. In other words, this is 3x plus 2. And if you set that factor equal to 0 to get the root, you come up with this equation. 3x plus 2 equals 0. Solve it for x. So subtract 2 and divide 3. So you get x is negative 2/3. Either way, you do get the answer negative 2/3. So just to show you, this can be approached from many different perspectives. I want to be honest, I'm not sure why this question was missed so much, but I think it was the fact that we have a binomial squared in it. And a lot of people don't like to deal with a binomial squared. Maybe it's a vocabulary issue as well. You do have to know what standard form looks like. Standard form for a quadratic. So that's the form ax squared plus bx plus c. Normally, if it's an equation, we'll say equals 0. If we're looking at a function, however, we'll just say y equals, or f of x equals. It says write this equation in standard form. This is a FOIL problem. It's also a order of operations problem. So let's go back to our order of operations. Remember, we have PEMDAS, as most people remember it. PEMDAS. That's saying what order do we perform operations when evaluating an expression. So we have to deal with parentheses and exponents before we can do any. This set of parentheses actually is being raised to an exponent. So we need to deal with this part first. Forget about the 3 and forget about the plus 4. We'll deal with those later. We go one at a time. So y equals, keep the 3 there. And we're going to evaluate what is x plus 1 squared. So in other words, it's saying what's x plus 1 times x plus 1. The plus 4 is still hanging out there. Okay, so let's go ahead and square that. Let's multiply. And if you FOIL, or if you do box method, you do get x squared plus 2x plus 1. And continue doing the order of operations. So we've already expanded that out. The next thing we need to do is multiply this 3. It's a distribution problem. The 3 needs to get multiplied by every term. So multiply 3 times x squared is just 3x squared. 3 times 2x is 6. X, 3 times 1 is 3. And the plus 4 just drops down. That's the last thing you evaluate. Y equals 3x squared plus 6x plus 7. If it now looks like this, where a, b, and c are just any numbers, we have standard form, and we do. So the answer is 3x squared plus 6x plus 7.